So I have the privilege of talking about AI for manufacturing, and it's a big passion of mine. I've been in manufacturing in some form of that for a very long time. And I have the privilege of actually knowing some of these folks. So without ado, I will introduce yourself.
Well, it's a pleasure for me.
There it is.
Thank you. It's a pleasure for me to be here as well. My name is John Dyck. I'm the CEO of an organization called CESMII, which stands for Clean Energy Smart Manufacturing Innovation Institute, which is a mouthful. We kind of go by the Smart Manufacturing Institute. We're funded by the federal government to bring this community together, the smart manufacturing community, which is the vendors, of course, the manufacturers, but the vendors, machine builders, academia, to solve problems that any individual stakeholder group can't solve. So we get to work with a lot of the great companies that are in this room. Thrilled to be working with you and your organization to figure out. We've got about a war chest of about $200 million from the Department of Energy, figure out how we can accelerate the innovation required to help make the U.S. more competitive through this vehicle of smart manufacturing. And so I'll leave it at that for now, but that's who I am.
Outstanding. Thank you very much. And so just as long, John, I've actually known Lexmark. Ironically, I've been working with Lexmark off and on, either from a government perspective or all the way as a partner perspective now since probably 1989, if that goes back for a while. So why don't you introduce yourself, and I want you to share a little bit about what Lexmark does,
is doing nowadays. Yeah. All right, wonderful. My name is Adam Rosenberg. Pleasure to be here. Thank you guys so much for creating this platform. It's great to get granular about different use of artificial intelligence and how it can impact a specific industry and give people something actionable to walk out with. So thank you, and thank you to the Endelman Institute for providing this platform. Lexmark, as you probably historically know, is a print company. So why are we standing here talking to you today? So we took our top engineers at its core, technologies firm. We have about 700 engineers on staff. We took our top engineers and moved them into this little satellite group and said, how do we take our intellectual property and intellectual asset that we learned from print and create completely diversified products and solutions? And from this little think pool was born a product line called Optra. When you think about printers, those are edge devices. They have hundreds of sensors in them. We just come to trust them to print out pretty pages for us, right? We are connected to our printers. We have 7 million distributed globally. And through managed print services, we're able to get intel on those printers for predictive maintenance, for color calibration issues, toner replacement, multitude of things. So we've basically been doing edge, IoT, and very print-specific AI for over 20 years. So those core engineers said, why don't we strip away the mechanisms from the embedded systems of those printers and create a series of light edge gateway devices that are used for deploying AI models at scale. And that's where really Optra was born. So I had business development specific to our Optra offering. It's a full end-to-end solution that from the edge and housing of those AI models. We do build AI models, but we also partner with great companies like BCD iLabs in order to fill our customer specific need quickly. Allison was talking earlier about let's meet the customer where they're at, and I think there's so much ambiguity and uncertainty around AI today. Businesses are sitting there thinking, where do I start? And that's kind of how I ended up personally here at Lexmark. Just to give you a little background on myself, I owned a manufacturing facility in South Florida. I made contemporary metal jewelry for some of the world's most luxury brands, from Tiffany & Company to Harry Winston, David Yurman. So I had all this equipment in my facility. And one day, one of my lathes, it was $250,000, stopped working. And it took me 4 weeks to get a technician from my manufacturer in Europe to my facility, another 2 weeks before it was up and running. So I lost 6 weeks of revenue and increased cost of repair like you wouldn't imagine. and just the painful calls that I had to make as to delivery issues. And I started down this AI rabbit hole. How could I have stayed ahead of the issues that I was experiencing on that equipment? And that's when I came across predictive maintenance models. I had sensing technology in all my equipment. I just wasn't connected to it. Then it turned into how can I replace human inspection with AI to increase my accuracy rates to 99.9% and inventory control. And so I ended up, I'm a curious mind and a nerd at heart. So I ended up down this AI rabbit hole. I ended up selling that business a couple of years ago, knowing that I wanted to work in this field. And as an SMB manufacturer, I was plagued with where do I start on that journey? When will I see return on investment? I outsourced my IT department. So how much IT resource is something like this going to take? So when I wanted to move into the world of AI, I was like, I need to work with a product line that really checks the boxes that I was plagued with as a business owner to allow that ease of implementation, that quick understanding of return on investment and, lack or marginal IT resource need. And that's really what Optra has built and delivered in our solution. So we're an end-to-end. We have a partnership with NVIDIA on our edge devices. We build AI models as mentioned and work with we're software agnostic, so we can house any AI models onto that to provide that security and that scalability on those edge devices. And our partnership with Microsoft Azure for that cloud connectivity so that you can manage whether it's you got 5 locations that you support or 5,000, we can now scale those solutions like never seen before. So that's a little on me.
Just a little. There's Bala. Now, Bala and I are close friends, but it goes beyond that. I think a lot of my friends would tell me that I'm always pushing the envelope out there, and then you got to surround yourself with great, capable people, right? And Bala's one of those people I surrounded myself with that I knew could help make those aspirations achievable. He's from Microsoft. Why don't you go ahead?
Hi, everyone. So my name is Bala. I work for a small startup called Microsoft. Have you ever heard? Very nice. Okay. So as he said, I work for Microsoft. I'm a chief AI officer for a West Midwest region. My day job is mostly talking to companies and helping them transform with AI. So I don't play very well too much into the product development, but what I focus is like for customers, how can they take AI and infuse into their existing business? That could be customers' product development or existing productivity, their processes, or how can they transform themselves and see the value of AI. That's my day job. My part-time job is to work for Michael. Just kidding. Just kidding. Uh, so I do help. He also know. We also have other passions. On the part time, we do help how to bring the AI skills into the university. So we built in Purdue. We built a smart factory. We also built one in CSI that you'll probably hear on the next session, I think. We have a real factory inside the university where students can come and get hands-on experience. Not a lab, not a bits and pieces of it. It's a real full-fledged line from start to finish. And we infuse AI into it. We have connected to cloud. We are creating courses for leadership as well as the students so that they can come and get a first-hand hands-on practical experience. So that can actually go into the manufacturing pool as the next generation skill sets. I mean, I know there's going to be a gap soon once the baby boomer starts. They start retiring. There will be a shortage of resource that we need to fill in. So that's my other passion. So nice to meet all of you.
And of course, after we'll be open to taking questions, of course, and make this very collaborative, throughout this moment today. So I want to do a stage setter real quick. The technology to connect the factory in many ways. What's wrong? Here. The mic. No. The mic wasn't working for the mic. Is it? So long story short is, John has an interesting background. and as a stage setter, I want to open up with that. You know, some people thought that it would be a great idea to figure out in the Midwest many years ago that, hey, we need to really look at tooling for manufacturers with some commonality and produce tooling and fixtures for those tooling in extreme ways, no matter what, and make that really common so people can access that. And that gave birth to a region in the United States still today, in the Ohio, Northern Kentucky, Michigan, Indiana region. It's still the tooling manufacturers are pretty heavy presence there. The reason I mentioned that was, you know, that was like 1910, right? Okay, then those same people were facing extinction. And that same region of America saw this new technology called robotics. They transformed much of their businesses into not just tooling, but robotics. Okay, and this is not the only industry this has happened. But I will tell you what I'm about to say is that the technology that was there and present and available wasn't being adopted. And it took different educational institutions, it took thought leaders, it took many, many people to build the skills to use for adoption. And that's kind of what's happened with smart manufacturing. You know, I mean, being able to do IoT has been around for quite some time. I built my own connected house back in like 2005. I forget, I think it was like 2005, 2006. I had a young child, and we had a person that was in my backyard at our sliding door. And having a young daughter, being a single dad, made me think that I needed to take steps to correct this problem. So, you know, think about it. Then if the technology was available then, why not now? And in fact, I've heard the excuses of, well, my plant's really, really old, really old. Okay. Lots of organizations have partnered with companies like CESMII and Lexmark for sensors, and Microsoft. I mean, Microsoft literally has an IoT lab to let you create sensors. So, and then they'll give them to manufacturers to go make them. So let's say that now the technology's now broken down to the hardware you need. That's not a problem. The edge servers that we're talking about, they're pretty robust. They're about that big. I did think about the hefty bag example earlier, and I wanted to share with you, maybe you should spray it with some John Cena scent. And then, you know, people will like it better. You know, spiced watermelon edge device. So, but my point to you is the tech's available. So ask yourself, why not the adoption? So that's my first question to this panel. Why not? If the technology is available, there's 150 MESs, clouds all available, edge, state-of-the-art edge, all available. Why not?
Can I start?
Yes.
So I'm not sure how many of you watch the data coming out of the Federal Reserve, but I began paying attention 4 or 5 years ago, shortly after I came to CESMII. Prior to CESMII, I worked for Rockwell Automation, responsible for their software business and some of their partnership and acquisition strategies. But manufacturing productivity for most of my career, since the Federal Reserve began collecting data here in the US, was on a steady incline till about 2010. And something happened around 2010 where, for the first time in our recorded history, manufacturing productivity in the US plateaued, and the last 5 years began declining. And so this is coincident with our manufacturing reshoring, friendshoring, nearshoring. And if we just happen to be doing so in an environment where manufacturing productivity is not, for the first time, and like I said, in recorded history, not growing. So that, I say that because that's the reality in which we're trying to determine how to become more competitive. My mandate with the funding I've been given from the federal government, I'm not from the government, but I have funding from the government, just to be clear, is to help manufacturers become more competitive. And so we're looking deeply. We've been looking, analyzing, studying, researching deeply into why that happened. And I would say there's two, and it's nuanced, but there's two fundamental categories. This gets to your question of, it's been 12, 13 years since we first announced the fourth industrial revolution. Why has the adoption not been what we anticipated? In fact, the US has fallen behind virtually every other major manufacturing region on the planet in terms of the adoption of smart manufacturing, which is why your question, and which is such a perfect tee up for us. There's two main buckets, I believe. Number one is what happened after the major financial crisis in 08, 09 was that manufacturers all of a sudden had access to free capital, and they changed the way they invest on the shop floor. They literally diverted capital spending from the shop floor into other ways of investing that they felt was going to, in the short term at least, drive more of a return. More germane to this conversation, though, is I believe that the last 3 decades of innovation on the shop floor and the last 3 decades of manufacturing systems, software, infrastructure, tools reached its limit. The plateau, the low-hanging fruit of continuous improvement, lean manufacturing, all of those initiatives to drive productivity on the shop floor is now curtailed by the decades-old infrastructure and the disparate systems that are on every shop floor in this country. And so there's a ton to dive in there, but from our perspective, our job then has been to recognize what is the root cause, and those are some of the sort of root cause challenges, and what can we do as we convene this community, as we convene the manufacturers, the machine builders, the vendors together to solve this problem in a way that no individual company can or stakeholder group can. That's the role of the federal funding that I'm challenged to spend to achieve these outcomes. And so, again, lots to be said there, but that's fundamentally, that's the way I think we see the challenge, the headwinds of adopting smart manufacturing, the complexity the technical debt we've created for ourselves, and also, though, recognizing that there's a huge opportunity to sort of move forward in a much more productive and innovative way. And AI is at the heart of that.
Yeah, I totally get it. Totally. So one of the other barriers was they always worried about their factories going down for internet or cloud connections, et cetera, right? And having enough compute power to be able to run AI models.
Yep.
So if I would, Lexmark, share with us, how is it that, yeah, great transition, by the way. I paid it. So.
Well, it's interesting you said, when you asked that question, the big word that was sort of blazing visually in my head was uncertainty and complacency. Businesses, in many cases, they're just unsure where to start in really embracing these technologies into their facility, plus they're operating. So it's almost like this understanding that this is a want. It would be nice to have this thing in my facility. I know I need to start exploring AI and how it will help improve my business and help me gain greater efficiencies and reduce my costs and increase my revenue. It's a nice want, but really needing to help them make that shift to this is something that you need in your facilities to operate better, to be leaner, to be more profitable. It's about return on investment at the end of the day. And security also being another key factor. So sort of segueing over to that edge philosophy, though, as you see this growth of AI, and if you look at any type of reporting, whether it's through IDC or Gartner, any of those reporting agencies, you see this huge catapult growth of AI. And parallel to that is the growth of edge, because you're securely storing that information on the edge where the information's being collected. I know with our Lexmark through Optra's devices, they're blankets of security on any AI models. So if we walk into a particular client, we're in the process of doing that together right now with BCDI iLabs, where they have sensing technology throughout their facility. They have cameras, they have vibrational and temperature detection sensing technology in there. Could be water detection or RFID scanners. All of these sensing technologies are collecting data for them. It's just, what are we doing with that information? So, when you think about Vision AI specifically, imagine storing volumes of video data. If you're inspecting, labels of product coming through your manufacturing floor, you're just looking for anomalies in that. You don't need to dump all of that and all that expenditure in the cloud. So safely, securely store that on the edge. It's the reporting that's realized through the AI models that's being generated. It's how that is being routed. Where's that information and reporting being routed to make that facility leaner again? It's how are we automating order processes when we have RFID scanners maybe built into a component casing that auto generates POs and takes that human element out so that you can now move that employment and those employees over to more revenue producing roles. So, edge is definitely a very important component. And I really do feel proper AI deployment is a hybrid of edge and cloud. Collect the data, condense the data, curate the data so that it's then fed out in an actionable way to business and stakeholders through our partnership with Microsoft Azure or whatever cloud that they're looking at to feed and share that information throughout the organization so that they can action it, so that they can understand my equipment is running hot or vibrating abnormally. It needs to be addressed before it breaks down, like I dealt with, unfortunately, and have that loss of revenue. So I think that that's really the thing. How do we ease the process of these manufacturers to start looking at this? It's not this pie in the sky solution anymore. This is something that you need in your business to be better and more effective, more cost effective, and more efficient. So there's this shift that's starting to happen, and I think it's probably not happening quick enough, at least for me, because I was on the other end of this thing. And I see the power of what it does. In our own Lexmark facilities, we implemented AI for quality control and replaced human inspection with AI models. And what we did was we got a return on investment in under 5 months. We were able to identify 19 additional use cases throughout our manufacturing facility to implement like strategies. And it's almost like this Trojan horse model, because once you put that footprint in there, and we were talking about this during some of the breakout sessions, is getting people comfortable. You don't need to start with everything. You can't boil the ocean, right? So what is your biggest pain? What is the customer's biggest pain? Where would they like to see more efficiencies? Start there. When they see it working and they see that return and they realize those efficiencies, they're going to organically want to, okay, how can that impact delivery notifications and inventory control and better order processing? Organically, they're going to want to start to move in these directions to say, how can these technologies, where else can these technologies be implemented throughout my organization?
Yeah, absolutely. So then when you're talking about that on those use cases, you brought up so many good use cases, right? So I know Microsoft's invested a lot in that, and whatever. And Bala has been involved in many of those. And I don't know if you know, but Bala actually had worked for 2 years. So not for them, but with them from the Microsoft side. They're very close partners. Bala, why don't you share with us, from this perspective of why don't they accept it on the floor? Why doesn't the plant, do this more often?
Where to start, where to finish? It's a long laundry list. Nevertheless, I think some of them that I see a lot in AI space is like the uncertainty that what is AI going to do? And then there's the fearness of AI is going to come and replace something. Not understanding how to infuse AI, what use cases to pick and choose, rather going and putting AI in places that AI doesn't fit very well. That being said, the other challenge is manufacturing has got this complicated software footprint in any plant floor. MES is just one layer. Every machine, every SCADA system, HMIs have their own mind and own madness to it. None of them share data, none of them talk to each other. Becomes extremely challenging in anything you wanted to touch on data. Digitization of factories are expensive ordeal, so the manufacturers are extremely scared to even touch it. Right? Sorry, I'm telling the truth. Sorry. these are very serious problem because if you want to build good AI, you have to be adaptable. We are very used to buying things and configuring and run it. When the technology is very nascent, you need to build. So you have to have that mindset. Nobody's willing to invest on building and saying like, okay, I'm going to take this chance and doing it. They're expecting somebody to do it so they can buy it. The ecosystem is not ready. So many different problems. These all are what like we see as a Microsoft. Now, as a Microsoft, we also have a challenge because we are a platform company. So we don't build very much on industry specific applications. So there is a maturity curve that the platform has to go to the software vendors and they adapt it. They got to be trained. They have to build something and then make it to the marketplace. Then the other challenge is like in the manufacturing plant floors, the employers don't provide opportunities to the workers to skill them up. You can't ask them to work 8 hours and then at the same time go study AI. So in Microsoft, our CEO was amazing. Like he said, like, okay, fine, you do 40 hours a week, do 80%, 90% work, 10% Friday, you know the drill. Take it for yourself and study, learn something new, right? They had this culture because that's how I learned AI. But I have been working in AI for 10 years. But as you know, the AI changes every day. So they allow us to adapt to the changes. That is not there also. So we have a lot more problems. The industry 4.0 is the same way. Like the technology was there, like Michael said, it never made it to the plant floor because the companies are so scared that they don't want to go invest the money. They don't want to shut down the plants. They don't want to try new things and see how effective it will be. They want somebody else to come and do it and then show them that this is done, it's proven, then go take it and use it, right? I think that mindset should change, to be honest. In this AI world, I don't see AI as a replacement because I use it every day. I have a programming background, by the way, but also I use GitHub Copilot. Copilot can write my code, so I don't need to be a programmer anymore. So what do, right? So I manage the Copilot, right? Simple as such. So like that, we have to use the AI to be very smarter. How do you take a regular worker and make them a knowledgeable worker? When you look at it in that lens, things will clear up. I mean, it's not going to replace anybody. I mean, I don't think AI is going to go start a machine and start building Coca-Cola, like compete with Coca-Cola, right? You need humans for it. There is so much in supply chain that AI can't do any, like a lot of those things. But where I've seen the success with companies who do them are the ones who are picking and choosing the use cases and implementing it in the right way. The other major thing I see is like everybody thinks this. Everybody thinks everybody's a perfectionist. I'm sorry to say, nobody's perfectionist in this world. So does AI. Don't expect AI to be perfect. Everybody who I talk to is like, no, it has to be 98% accuracy. As a human, we are not 98% accuracy. How are you expecting the system to be that? That expectation has to go down. You have to start with saying like, you know what? 40 is better than 0. If I'm 40% successful, I will take that shot. Or I'll go 80%, I'll go 70%, and I'm okay with it. Put the human, let the remaining part human do it, right? That mindset has to change. These are the challenges that I really see. Using the technology, is it doable? Yes, it is doable. The Innovate platform, we actually did it. We can use AI, augment the researcher to do the work. You don't have to take the researcher's work out. I used to do mundane tasks of sitting and writing emails and writing documentations and things like that. Now all I have to do is like describe what I want. ChatGPT, OpenAI will give me the content. I just have to modify it. 2 hours of work, I'm done in half an hour. That's how I see. So AI has helped my productivity. AI has a potential to help other productivity. Like we did Factory GPT for CSI and then for BCD, we did the Cheese GPT. The reason was like, hey, you have so much compliance information that is available, but even if I'm the cheese expert, I can't tell you all the compliance in the world because there are documents after documents government has put out. But you can have a tool that I can go ask a question and it'll give you straight answers. All this time we have used Google and we have been successful, but Google is always giving you links, but you still have to go spend the time to read the links. And we assume that all the data that Google provides is truth. That is the biggest laughable joke I can see. But that being said, when we spend time over there, you can convert that with ChatGPT and say like, okay, I want to know how to clean a cheese plant, manufacturing plant. It gives you step-by-step instruction. It's actually Michael's project, actually. He should show the demo. You guys should all see it. It actually gives the information that I need, not the one that I have to go do research on. So I can do my job much faster and better instead of going back and again searching for stuff where it is and whatnot is, right? So those are the challenges. I can go on and on and on, but I don't want to bore you.
So now you've heard some of the challenges as to why it hasn't happened at scale, right? And we've got the technologies available, the edge compute's available, right? The know-how's available. And we know that there's already accelerators available, right? So I'm going to get to that after my next question, because the accelerators I really want you all to be aware of. There's ways to accelerate this journey to catch up. So in the food and beverage industry, it's unlike some of the other manufacturing companies. There are other personas that care about what's happening in the plant that don't sit in the plant, right? There's a head of quality person. There's a product owner or whatever food product you're bringing to market or that you're making. There's an engineer that has an interest in the factory, right? And there's an R&D person who's tied to this. Let's think about it. The R&D person is creating something, and what do they have at their hands? They have data that they use pass fail to make it, and experimentation, and a map of how to make it, right? What happens next? I'll just email it here. I'll just email it, or maybe I'll call them. I'll just tell them, hey man, we're going to do a substitution. Those days that are going to be behind us. The technology then is that I can now hand that to the engineer. The engineer can simulate using that test data, pass-fail data on formulation in the process, send that to the factory, and then all of a sudden, who really cares about the data from the factory? The R&D people, engineering, right? The product owner and quality. Just one other person's out on the factory, but they're the ones not adopting it. But now we went from one stakeholder to 5. And that's why we believe that in AI, it's going to empower these 5. And now it will happen. Why? Because just like engineering orders a machine, engineering orders a controller, just like any other thing on a network, it's now going to be forced towards the factories. It just will be a part of operating nature to go do it. I believe that time is coming, but we're not there yet, right? We're not there yet. So then I'm going to go to my next question, which is for you all. Let's want to start on with Lexmark here, because I know that I've been to your factories and I've been to Funai. I bet you didn't even know that I helped open Funai, and I opened your facilities and engineering in Philippines.
Wow.
So with you all, and I know that you all have started connecting things already long ago. What's the value after you do it? What was the value all of a sudden when you guys started connecting things and using vision and AI throughout your enterprise? Talk to them about that.
Yeah. So, value to just talking about Optra solution specifically?
Yeah, what
or-
you see is the value that's happening.
within our own facilities immediately, again, we're able to reallocate resources internally. We're able to take people who, where we were able to replace them with these different models and these different tools and are able to reallocate those resources. We're able to get better insight into asset management. Where is the inventory within our facilities? Where is it being tracked? How is it, when deliveries are picked up, that we're able to track and have insight into where, making sure that our customers are receiving product in the time and the place that they need them. And also having facilities, everywhere from Asia to Mexico, manufacturing in Mexico, as well as distribution centers here in the US, is all of a sudden, all of this information was now bridged. We now had insights into where, where everything was housed and making sure our customers are having a better experience. It allowed us to be more efficient in distribution of our product. Again, I shared earlier, of course, replacing quality with AI models, we increase that accuracy rate. We are an OEM manufacturer for other brands as well. So making sure that a Lexmark product is going into a Lexmark box. When you had, humans really visually inspecting those things, there is room for error. Occasionally that will happen, but you don't want to send a Lexmark product and they open the box and all of a sudden there's a different product in there. So there's so many different ways that this is even down to the component level. And being able to track components that go into our products, making sure that we are, becoming more sustainable in the products that we deliver. And we have a huge sustainability story behind what we do. But also making sure that all components are housed and on shelf. If we have different suppliers, NVIDIA takes X number of weeks to deliver these chips to us and these components to build panels onto, the raw materials take another, X weeks, that we're able to have more effective and efficient insight into order processing, rather than a lot of the guesswork that was happening before implementation of these models.
Well, now we're working together. We're early stage with a company they do mushrooms.
Yes, correct.
Okay. And so you take here's the reason I asked him this, because you would think this wouldn't apply to food, but that does.
Yeah. Oh, so you're talking specifically
that's
to
why I asked
our
you.
end customer experience.
No, I was talking I wanted you to talk about their transformation journey.
Yeah. And this,
but the lessons are very clear. You can learn from what they did to put it in a food environment.
yeah.
And we're putting it in an environment that they manufacture. What they do is they take the biome from fungi, from mushrooms, and they use it for different applications.
Yeah, sorry, I thought you were talking about internally within Lexmark. So, but specific to Optra and an end customer experience, very antiquated facility, large manufacturer and producer for a variety of different brands and produce. Right now, a completely manual process, and BCDI is instrumental in delivering that solution fast to fill this need because it's so inefficient. It is a completely manual process. They're shutting down the manufacturing floor. They're pulling and inspecting to make sure that the labels have the correct UPC, that they have the correct sell-by dates, that they have it's the correct style of mushroom, as well as the correct brand, similar to what we experience at Lexmark. They're an OEM distributor for a variety of different mushroom companies. All of this information is entered, and they're on these large thermal printers, and so they have to ensure accuracy on every one of those labels. Currently, again, they're breaking it down every 30 minutes, doing a manual inspection of this, and we're going to fully automate that process for them by mounting a USB port camera onto this equipment, processing the BCDI skill on our Optra device, and being able to have better insights into making sure that every piece and every label is properly accounted for, as well as, they have certain reporting standards. And you were talking about external influencers in our businesses today. They have certain reporting and standards that they have to adhere to. So if it's a 1 year or a 3 year retention rate to make sure that that information is captured, it's kept, we house it on an edge device. Where is that information then routed to? What action do they want to see in the AI model to make sure that it's being fed and directed into a repository where it can be later extracted if needed? So all of that, now we're going to fully automate that process for this facility.
For a company who arguably was extremely,
Yeah.
so think about what I'm saying, extremely manual. And the future will be that they'll be able then to go backward into formulation and help their sales teams with more product to be able to get out there on samples, more rapid response. That'll be far off in the future, but that's where we're moving to. Now, for you, I want to ask you, John, say they want to get an accelerator. So now we already know they've got some, we've got our systems. What accelerators do CESMII provide to help people in the food and beverage industry to start getting connected factories?
I'd love to answer that. I'm going to take 60 seconds to answer that question first. Over the 25 years I've been in, specifically in this space, kind of the industrial IoT, smart manufacturing space, we've done the analysis to discern that going from a non-digital reporting, KPI, OEE, production monitoring sort of environment to a digital reporting environment, on average, you will find 25 to 30% capacity in your existing plants with your existing people, your existing assets. That's just there.
Wow.
And available for you to find.
For the taking.
Unbelievable, right? So in terms of value, and it doesn't matter whether it's an automotive tier 2 supplier, aerospace and defense, food and bev, pharma, doesn't matter. 25 to 30% existing with a new capacity with the existing resources. So that's a very, very simple and powerful notion. Now, what do we do about that? Getting back to our mandate, which is to use the funds that we have to work with this community and actually cut the cost and the time to implement these systems by 50%, which we've done. And our objective there is to commoditize the infrastructure required to move the data from a real-time source like a sensor or a PLC, a robot, a machine tool, a piece of equipment or a process, and make it available to the application, which is where the value creation is, right? We know that it's the rule of thumb, 80% infrastructure, 20% value creation. That 80% needs to be commoditized. And that's the piece we've been tackling. It's not fun. I shouldn't say it. My work is fun because we get to help manufacturing, but infrastructure is not, plumbing is not what anybody wants to focus on. And yet that's where the massive transformation will come from. That's where the massive productivity gains will come from. We often talk, Amazon and Microsoft are great partners of ours. Amazon, just to give you a really simple example, Amazon has this cool little sensor thing called Monitron, where you peel and stick these sensors on a piece of equipment and presto, you can do something really quick for low cost. The challenge is that's one of another set of data silos and stovepipe architecture. So if the temperature that you're getting from that Monitron sensor is required for a quality application or a maintenance application or an OEE application, you've got to plug in another sensor because that's in a data silo over there and you can't get it in this application over here. And so that notion of propagating stovepipe architectures and data silos is absolutely at the root cause of our inability to be agile and to innovate and to create value. So I love what's been said here because this notion of solving these problems is fundamentally the value creation. Our job is to create and provide and fund the creation of the infrastructure that will get you to that value creation much, much more quickly. And so without getting into the details, we issue RFPs. We're about to issue an RFP around connecting a manufacturer with 8 or 10 of their suppliers, so the suppliers can exchange real-time data with their manufacturers about product quality, product availability, about whether or not you're available to ship as you forecast or not. That sort of modern version of an EDI for manufacturing operations, that's one of the next problems we're going to fund. So anyway, that's our job, is to find out how we can solve these problems, go out to the community and say, help us solve real, tangible manufacturing challenges like this. So if we have time anywhere today, I'd love to talk about a great project we did with McCain's, with General Mills, with Tyson Foods, around using AI to solve really important problems. but not in that sort of isolated data silo approach, in this interoperable approach. If there's one idea, I think that's at the heart of this focus on reducing cost and complexity and the democratization of smart manufacturing, it's interoperability. How can we collect data from the plant floor once and make it available to 1,000 AI models, make it available to my MAS, make it available to my asset management, make it available to my quality system, and not recreate that infrastructure for every single application.
No, I totally get it for sure. And I didn't realize that you'd done that. So I'm going to come back to you for you to talk about some of that AI piece, okay? Because I think that'd be great and very applicable for everybody to hear, right? Bala, some of the projects that we've worked on together around AI and some of the roadblocks and the challenges we've overcome, what are some of the greatest successes that you saw out there?
So that depends on the use case that we tackled, right? Some of the use cases like vision-based quality measure, like I usually say when I can see and detect, then the vision system can go and see it. If your naked eye can't see it, then if you're going after a goof chase. Depending on the use case that we hit on, we have seen successes. We have seen production successes. Like, I mean, I have seen customers who are really right now using AI in the production scale. But it also comes with some challenges. We also, the other success that we have seen is like customers who put an AI system and then they collect more information, like data set, like images from the real plant based on the real scenario, and giving the feedback loop into the model and retraining the model makes it much more successful. These are the primary successes that I've seen in the vision side. In the predictive maintenance side, it's been a very hit or miss because the biggest challenge in predictive maintenance is like you cannot collect data from any of these equipments that it sits in the like for 10 years to 70 years worth of ages of equipment sitting in the plant floor. Audio-wise, we have been very successful. You can do vibration analysis and apply AI to vibration analysis, and that has been another huge area of focus for us. Then comes the Gen AI. Gen AI has been the most quicker success because it becomes your knowledge buddy. You can just implement it in very low cost. You don't have to go rip and replace digitize the factory or anything like that. For that matter, you don't even need to replace any of the software tools that you're using. You can augment it with it. So these are some of them that we have seen. I mean, we have case studies after case studies. I can't bore you with that. But Rockwell is actually a very good story. I mean, even a Rockwell Twinsburg plan, we did AOI. We took an idea to say like, okay, why should we use an advanced optical inspection system? Why not use AI? We wrote our own deep learning code, and it was a great success. So take a small piece and prove it out and see whether it is working or not. It will work. And then take that model and apply to the remaining equipments. The moment you go all in all full, then it becomes a challenge. So that's what I've seen.
Okay. I've done some many projects together. We both love Vision AI. We love using inspection. We love using a lot of the production and improvements for yield. I myself have witnessed over and over, time and time again, without fail, yield improvement on a food menu or beverage manufacturing. And it didn't matter if they made flour, ingredients, or soup. It was always the same. The yield varied in the gain, but the gain was always far greater than what we even thought it would be. So it's definitely a lot of success out there, and moving towards, to some degree, some standardization and democratization. So I want to talk to you, John, about, you mentioned some projects that were done. Let's talk about some of those real quick.
I'll summarize a few very quickly. A project with two projects with General Mills that we funded. The first one was many years ago when General Mills was challenged with the reality that the gluten-free thing that was on the box didn't actually mean that there was no gluten in the box, right? So we invested in a massive system with them to literally go from the farm to the factory where they're actually making Cheerios. And that involves entire supply chain traceability from the farmer's field to the trucks, the trains, the barges that are moving the grain from the farmer's field to a silo, from a grain silo to another barge, a boat, to a railroad car, to a flour plant that's going to grind these oats and create the flour, and then that flour ends up at an actual Cheerios manufacturing plant, one of 3 in the U.S. And they obviously had to go through this incredible process using some very sophisticated tools and AI, particularly AI, to ensure that out of every million grains of oat or some sort of grain coming into the factory or coming into the flour mill and then into the factory, less than 12 parts per million were not oats. That's the stat for what's required for it to be gluten-free. So just an awesome project that roughly, aside from the brand value of ensuring that gluten-free on the box means gluten-free in the box, $20 million a year of value creation for General Mills. Another General Mills project was, and I'll keep this brief, was of a very different nature. They had a yogurt plant that was this was a sustainability-centric project, highly instrumented with energy management, power measurement devices at the machine level. And they had another yogurt plant in a different part of the country that had virtually no energy management devices. And so we created sort of AI models for every class of equipment that we trained based on the plant that was instrumented, the compressors, the equipment, the conveyors, the blenders, the whatever, the vats, the pumps. We built models for every class of equipment. We refined them and then moved those over to the other plant that has 0 energy management equipment. And we're able to predict energy production, energy consumption. And obviously from there, you can begin training and tuning and helping the operators figure out how to reduce their energy consumption with no investment in energy management, physical hardware. So an awesome little, and I shouldn't say little, an awesome project that proves out how we can lift something, use AI to train the model here, and then apply it in a very low cost, democratized way there. Yeah. The McCain's project was fascinating in that it was kind of a farm to fork piece as well, where we tracked the potato from a farmer's field through all the transportation mechanisms, logistics, to what that potato looked like as it was reaching the point where it was cleaned and cut up into fries, and then the quality and the quantity and the optimization of the fry product that came out of that potato of that type from that farmer's field. And then obviously the company can then work to optimize all of the details around which farmer to invest in or what kind of potato results in this kind of yield and so on and so forth. A very cool AI project.
So, I mean, you're hearing testimony about the successes that have occurred. You've heard about some of the obstacles of why it hasn't happened yet. You heard me say some things around new stakeholders that I think are going to influence the buying cycles to deploy connected intelligent factories, because they're going to want that feedback loop in food and beverage specifically. You've heard how lessons learned from similar industries were applied and how we use that for foods and manufacturing together on our even most current. There are accelerators available. If you go out to look at CESMII, right? Not the only one, but it's the one I like the most. I've been around many, and they seem to be more focused on the value and democratization, and the plumbing, which is more if you're going to find the roadblocks to trip you up outside of people, that's the roadblock that will trip you up. And then you heard about how Microsoft and Bala has been involved in many, many things, and he's one of many of an army, but he's my favorite. He's had a lot of successes around this. So I want to thank you all very much, and I want to be able to open it up to some questions. Anybody?
Good. Does everybody need coffee? Yes?
Well, we did go right after lunch. Fair.
We can open it up as, like we did the last panel. Have them come over and talk to the panelists.
Absolutely.
Smaller group.
So if you want to do that, I know that I've got some persons who are on the education path. We've got persons who actually have projects that have been deployed. We have people in the room that actually are starting their journey. So we'll go ahead and take a break and give you an opportunity to talk to them and get more one-on-one around what maybe some of your questions would be. All right, thank you.